So in 2.2, we're going to review how do we graph and then how to rewrite equations for linear functions. So we're going to start with graphing, and we're always going to graph our lines in slope-intercept form. It's just the easiest, so that's what we're going to do. So what I've given you up top are these steps for graphing, and we will go through these steps and look at problem number 1 all at the same time. So the first thing you want to do is make sure that your equation is written in that slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So if we look at number 1, that's already done for us. This is already written in that y equals mx plus b form. So we don't have to do step number 1, so that's nice. Now that it's in y equals mx plus b, the first point you're going to want to put on your graph is the y-intercept. Remember, in this equation, your y-intercept is the b value. So this means that the y-intercept of your graph is the point 0, 4. That is a point on your graph. B is the y-intercept. So you can go to 4 on the y-axis and plot a point that is on your linear function, that is on your line. Now that you've plotted that point, step number 3 is to use your slope of the line to create more points. Because remember, our slope is that ratio of rise over run. So we have a vertical change over a horizontal change. So our m in this case, which is our slope, is a -2. And if we write that as a fraction, that's -2 over 1. So our slope, our line, is going to be decreasing because we have a negative slope. So what I like to do is go down, so I have like a negative rise, and then I go to the right. You could also go up and left. Either way, you're going to get that negative sloping line. So from this point, I would go down 2 to the right 1, plot a point. Down 2 to the right 1, plot a point. Or again, I could go up 2 and to the left 1. So all you need is a couple points to make a line. Once you've graphed those few points, connect them. This is what step number 4 is. Connect your points, placing an arrow at both ends just to show that that linear function is continuous. It doesn't stop at the minimal points that we made. Okay? All right, so moving into number 2, we have x plus 2y equals 6. Now 2 is not written in y equals mx plus b. So before we even start graphing this line, we need to rearrange it so that it is written in that y equals mx plus b form. That way we can start at the y-intercept and then use our slope to make more points. So the first thing we're going to want to do is move this x over to the right side. So since it's positive on the left, when we move it over to the right, it's going to be negative. So we'll have 2y is equal to -x plus 6. Then to get the y by itself, we're going to divide by 2. And remember, we practiced this in our intro, but you need to divide both of these terms by the 2. So what we're left with is y is equal to, the coefficient of this x is a -1. So this would be like -1 divided by 2, which doesn't divide evenly. So we just leave that as the fraction, -1/2 x. And then you can divide this evenly. So 6 divided by 2 is 3. I didn't mean to make both slopes negative. I'm sorry. So just remember, if you have a positive slope, it better be going up from left to right. Okay? I know, my bad. All right, so again, now that it's in this y equals mx plus b, we know that our b value, that's the y-intercept. So we're going to go plot a point at 0, 3. So the y-intercept is 0, 3. And then our slope is already in a fraction, so that's good. So it's a -1 over 2. So that means I'm going to go down 1 and to the right 2, or up and left. Either way, as long as we go left or negative in one direction, we'll have a negative sloping line. So down 1, right 2, down 1, right 2, or I could go up and left 2. And I still have that negative sloping line. Again, make sure if you have a positive slope that that line's increasing as you look at it from left to right. All right? Our next two examples I wanted to give you because we cannot forget about our non-slanted lines. We have two types of lines that aren't slanted, horizontal and vertical. So numbers 3 and 4, what you'll notice is that each of these equations only has one variable, not both. They don't have a y and an x. This is just y equals 3. This is just x equals -2. So these are the examples of our horizontal and vertical lines. So remember the acronyms HOI and VUX. Do you guys remember that from Algebra 1 or Algebra 2? So that acronym HOI VUX, this HOI is to remind you that horizontal lines have a slope of 0 and their equation is y equals 3. So if this y equals whatever number, this one happens to be y equals 3. So what this means is we're going to have a horizontal line that goes through the y-axis at 3. And that line's graphed, and you're done. So we've got a horizontal line that goes through the axis at 3. And then the acronym, this VUX, is to remind you that vertical lines have an undefined slope, and their equations will always be x equals wherever they go through the x-axis. In this case, it goes through the x-axis at -2. So we're going to draw that vertical line that goes through the x-axis at -2, and then we're done. We've graphed x is equal to -2. Any questions on graphing? Okay, then the next thing we're going to look at is writing equations from 2 points. You could be given this in a lot of different representations. You could just be given 2 points. You could be given a graph. You could be given a table. You could be given it in function notation, which we're going to go over. So no matter which format or which representation you're given, the process is going to be the same. All right? So step number 1 is always going to be to find the slope. Then, once you have the slope, you're going to use that slope and 1 point to write the equation in point slope form. And as a reminder, point slope form is y minus y1 equals m times x minus x1. So this form of a line is going to allow you to write an equation as long as you have a slope and a point. Hence why it's called point slope form. Mathematicians weren't very creative. They said, I got a point and I got a slope. Let's call it point slope. Okay? From this form of an equation, we can distribute and then simplify and get that y by itself so that we can convert it from this form into slope-intercept form. All right? So let's practice that with these next couple. The first one I've given to you as a graph. Now, if you could see the y-intercept, then you wouldn't have to do all this work. You could just find the m, the b, and write it in y equals mx plus b. But this is an example where you can't see the y-intercept, so you're going to have to use that point slope form. Okay? Now, when we find the slope, which is step number 1, they've already given us 2 points, so we can just count, rise over run, like we did yesterday in our intro unit. So we're going to rise 1, 2, 3, and then we have a run of 2. So the slope of this line is 3 over 2. Now that we know the slope, we can choose either one of these points. It doesn't matter which one. Mathematically, it should come out the same. So I'm going to use this point right here because they're both going to be positive. So that's the point, not -1. What are you doing? +1. That's the point 7, 1. So now that I know the slope and now that I have a point, I can use my point slope form. So I can plug that into y minus y1 equals m times x minus x1. Because my point will get plugged in for the x and y1, and then my slope will get plugged in for the m. So this will be y minus the y1, which is 1, equals the 3 over 2 times x minus the x1, which is 7. Now that it's in this form, I can distribute. So I'm going to bring down the y minus 1 equals 3/2 x minus 21/2. And then now all I would have to do to get the y by itself is add the 1 to both sides. And that's going to give me this equation in slope-intercept form. It's going to be y equals 3/2 x. And then when I do negative 21/2 plus 1, we get what? You have a calculator, put in negative 21/2 plus 1. Y'all are being lazy. It's not negative 10. What is it? No. Put it as a, I guess technically you might be right, but put it as a fraction. Plus 1. And then do second, and then turn it into a, there we go, negative 19 over 2. Thank you. All right, so that's not a very pretty y-intercept, but that's one of the reasons why we would have to find it algebraically, because even if it went through the y-intercept, it'd be pretty hard to tell like exactly what that value was. So we'd find that algebraically using this point slope form. All right, number 6. Given p of x with the values p of 6 equals negative 11 and p of negative 3 equals 4. So what this is an example of is writing an equation when we're given this value in the function notation. So what we have to remember about function notation is what they're giving us right here is we are given a point. Because function notation says if this is the x value, this is the y value. When x was 6, y, the output, was negative 11. So what they're doing in this case is giving us the point 6, negative 11. Which then, if they give us this other point, this means when the input was negative 3, the output was 4. So this is the point, negative 3, 4. So using function notation, they've given us 2 points. And now that we have 2 points, we can easily write the equation for the line. So the first thing we will need to do is find the slope. So we can say like this is x and y1. This is x and y2. It does not matter. It will end up the same. Good question. All right, so now we will plug these into our slope formula that we practiced yesterday. So we'll do y2 minus y1. So that would be negative 11 minus the 4 over x2 minus x1, so that would be 6 minus a negative 3, but minus a negative is a plus. So negative 15 over 9, but negative 15 and 9 are both divisible by what? 3, so we're going to simplify this down to negative 5/3. Maybe I won't put a circle around it because that's not our final answer, but that is our m. So now we have that our m is negative 5 over 3, and we have 2 points to choose from. And it doesn't matter which one we choose. Anybody have a preference? Okay, we're going to use this point. So what we're going to do is use this point and our slope and plug it into the point slope form. So this is going to be y minus y1, which is 4, equals the m, which is negative 5 over 3, times x minus x1, but since we're minusing a negative 3, we're just going to make it x plus 3. Very good. And now that it's in that point slope form, we're just simplifying it to y equals mx plus b. So I'll distribute y minus 4 equals negative 5/3 x minus 5. And then I'm going to add the 4 to get the y by itself. And in slope-intercept form, my equation is y is equal to negative 5/3 x minus 1. All right. The next two, I wanted you guys to have these examples because you will continue to see these non-slanted lines, so I wanted to make sure you had some on your notes. But number 7, we're writing the equation of a line that passes to the point 2, 7 with an undefined slope. So what did we just go over? What kind of line has an undefined slope? Vertical. Remember the VUX. A vertical line has an undefined slope, and the equation is x equals. So undefined slope, vertical line. Again, the equation is x equals. And if I'm given this point, that means this line has to go through the x-axis where? Just the x. X is equal to 2. Since the x value of this point is 2, that's what our equation has to equal, because we're going to have a bunch of vertical lines, 2 7s, 2 6, 2 5, 2 4, 2 3, 2 1, 2 0, 2 negative 1. All of my x values will always be 2. It is a vertical line that goes through 2. And then 7 or 8 is similar. It passes through the point 5, negative 3. This time it's got a 0 slope. So what kind of lines have a 0 slope? Horizontal lines. That's our HOI. A horizontal line has a slope of 0, and the equation will always be y equals. So that means the equation that goes through this point is going to be y equals, where will it go through the y-axis? At negative 3. If this y value is negative 3, that has to be the y value of our line. So our equation is just y equals that y coordinate. Okay, the last thing that we are reviewing in this section is parallel and perpendicular lines. So this is a way that they inadvertently give you a slope by telling you lines are parallel or perpendicular. So parallel lines, just as a review, those are two lines that are graphed that are never going to intersect, right? Because they have the same rate of change. They're changing at the same rate but different y-intercepts. So when I say they have the same rate of change, what that means is that their slopes are equal. Parallel lines have slopes that are equal. Or the same. That's fine. Then the other type of intersecting lines are our perpendicular lines. And what's special about perpendicular lines is that they intersect at a 90-degree angle. And so because of that, their slopes are always going to be opposite reciprocals. Opposite reciprocals. Now, some of us struggle to remember what that means. Opposite means like positive and negative. So if one's positive, the other one's negative. That's what opposites are. The opposite of positive 5 is negative 5. Okay? Reciprocal is when we flip the fraction. So the reciprocal of 1 over x is x over 1. when we flip the fraction. Those are reciprocals. So you have to do both of those things with perpendicular lines. It's got to be the opposite, and we got to flip it, okay? So these next two questions, we're going to practice that, so you have one of each. Number 9 says, give the equation of a line that is parallel to 2x minus 11y equals 4 and passes through the point 2, 4. So if these lines are parallel, I know that the slope for my line is going to be the same as the slope of this line. So again, like inadvertently giving you the slope, except how rude, because this is not even in y equals mx plus b. So I don't actually even know the slope yet. I have to do extra work to rearrange it. So let's quickly do that. We should be very comfortable with moving the x's over to the right side. So we've got negative 11y equals negative 2x plus 4. Then we divide by the negative 11. And again, we're going to divide all the terms by negative 11. So this is not going to divide evenly, but when we simplify a negative divided by a negative, this slope is actually going to be a what? Very good. So this is a positive 2 over 11x. And then we don't really care about the y-intercept, but it's negative 4 over 11. But we don't really care. The only thing we need from this equation is its slope, because our slope is going to be the same, because the lines are parallel. So the point that we're going to use is this 2, 4. That's our x and y1. And the slope we're using is 2 over 11, because the lines are parallel. So we use this same slope with this line, plug it into point slope. So that's what we just practiced up top. So when we plug this in, it would be y minus y1, which is 4. And that equals m, which is 2 over 11, times x minus the x1, so minus 2. All good? Okay. Now that it's plugged into point slope, again, we're just using more algebra. We'll distribute this, simplify it, get the y by itself. So we have 2 over 11x minus 4/11. And then we'll add this 4 to negative 4/11. And let's write it as an improper fraction, but it seems like a crazy number. But negative 4/11 plus 4. Logan, tell us what it is. Yeah, you all have machines that will do this for you. They're called calculators. Pick them up. Negative 4/11. So now do second and then hit the fraction key. No, not the back arrow. Hit the fraction key. There you go. What is it?
40 over 11.
Very good. So plus 40 over 11. Looks funny, I know, but your calculator will get you there, so use it. Okay. So now let's practice that one more time, this time in number 10, just so you have an example. This time we're giving an equation with a line that is perpendicular to 12x minus 6y equals 3, and it passes through the point negative 1, 3. So we're writing an equation that goes through this point and has the opposite reciprocal slope of this equation. Again, so rude. They couldn't have just given us something in y equals mx plus b. We got to put it that way to figure out the slope. So let's move this 12x over to the other side first. So we get negative 6y equals negative 12x plus 3. Divide by the negative 6. Negative 12 divided by negative 6 is going to give me a positive 2x. And then 3 divided by negative 6 gives me negative 1/2. But again, We're not really concerned with the y-intercept. We just need that slope. So if this equation has a slope of 2, it is going to be negative. But there you go. It's a negative 1/2 because we have to make it the opposite sign. So since 2 is positive, our slope is going to be negative. And 2 over 1, when I flip it, is 1 over 2. So it has to be opposite and flipped for perpendicular. So we're going to use negative 1/2, and we're going to use this point, that negative 1/3, and we're going to write the equation of our line. So now it's just, again, we've practiced. Let's practice it one more time. Plugging it into point slope. So this is going to be y minus 3 equals negative 1/2 times x minus, but we're going to minus a negative 1. So instead of minusing a negative, we just put positive 1. And again, now we just use our algebra. Let's distribute y minus 3 equals negative 1/2 x minus 1/2. And then we'll add the 3 to get the y by itself. And the equation of our line is y equals negative 1/2 x plus 5 over 2. And hopefully you know how to get that by using your calculator. Good. Okay, so that